Sketch the graph of y equals 1/2 x plus 4 times x minus 2 times x minus 5 on the set of axes provided. Clearly label any axial intercepts with their coordinates. So the first thing we're going to find is the y-intercept of this graph, and that occurs when x is equal to 0. Substituting x equals 0 into this rule gives y equals 1/2 times 0 plus 4 times 0 minus 2 times 0 minus 5. Evaluating that, we get y equals 1/2 times 4 times negative 2 times negative 5, and that is going to equal positive 20. Therefore, the coordinate of the y-intercept is 0, 20. Next, we can find the x-intercepts of this graph, and that happens when y is equal to 0. So we're going to solve the equation 0 is equal to 1/2 x plus 4 times x minus 2 times x minus 5. As this is already in factorised form, we can use the null factor law to say that x plus 4 could equal 0, x minus 2 could equal 0, or x minus 5 could equal 0. Subtracting 4 from both sides of this equation gives x equals negative 4. Adding 2 to both sides of this equation gives x equals positive 2. And adding 5 to both sides of this equation gives x equals 5. Therefore, the coordinates of the x-intercepts is negative 4, 0, 2, 0, and 5, 0. Inspecting our rule, we can see that it's going to be a positive cubic graph because there's no negative symbol in front of what will become the x to the power of 3 term. So that means it's going to have a shape something like this. So on our graph, we need to draw it so that we have x equals negative 4, a turning point, y equals negative 20, x equals 2, and x equals 5. So that is the shape of this graph. Labeling all those key features, we have this as negative 4, 0 as the first x-intercept. Our next x-intercept is at 2, 0, and the third x-intercept is at 5, 0. The y-intercept was at 0, 20. And for this question, we won't label the maximum and minimum. However, on this slide with the computer-generated graph, you can see the decimal approximations of the maximum and minimum turning points on this graph for you. So as you can see, all the key features are the same, and that is the shape of this cubic graph.